I'm going to focus back in Albuquerque this time. And I'm actually going to be talking about the same restoration sites that we were talking about earlier, but from a specific perspective of sediment. And I think this actually ties really well into what Todd was talking about and kind of the sediment dynamics in these restoration features. But these features are quite a bit older than being built in the last year. They originally were built in 2008, or some of them began to be built in 2008. And here they all are in all their glory. So specifically the reach that I'm talking about starts near Sandia Pueblo, or in the Sandia Pueblo, and all the way south to the I-25 bridge down here. I think these are all the sites. I had to double check a couple of them, but I think this is all of them. And I like this figure because it shows us that there's actually quite a bit of work that's been done in this Albuquerque. There's obviously, a significant percentage of the bosque near the Rio Grande itself has kind of been actively rehabilitated or restored in the last decade or 2 decades, I guess. What I'm focused on in terms of what we're focused on in terms of these restoration features is, of course, what we've been talking about for the last 2 days now is habitat for specifically the silvery minnow and the Southwest willow flycatcher. Another kind of some secondary goals of these features is to promote overbanking into these surrounding bosque and removing some of these non-native species. And specifically, we've revegetated these sites with native species such as willows and things like that. So, and there are 3 primary types of restoration that I'm focused on today. The first one are these channelized flow features. So it's high flow channels or backflow channels. Like the one here, this is in March, I believe, or February, I believe, of this year. And you can see some parts of this has already been being inundated from kind of spring runoff that started. And another type of feature is a swale feature. So these are inland depressions that are primarily groundwater fed. And some of them in more recent years, we've kind of adapted the way we've constructed these by connecting these swales to backflow features or high flow channels. So there's kind of 2 types of swale here, one that's connected via some sort of high flow channel and ones that are disconnected, and they're simply mostly groundwater fed. And then finally, bank line. So this is at the 3A site, the Oxbow site. I'm looking down on a constructed bank. See, it's in this clear sloped area where we've actually treated the bank of the Rio Grande and revegetated with willow. So we're talking about these restoration features, so we're really specifically talking about only times when the Rio Grande is above about 1,500 CFS. And the way we've gone about evaluating these sites in the last year is using high-grade, survey-grade surface measurements, topography using RTK GPS. So the data I'm going to show today is exclusively from those measurements. And we certainly can look at differencing LiDAR images and things like that. But what we wanted to do with this specific work was to look at a series of cross sections and see how they specifically have changed in as best quality of data, elevation data as we can get. And that's RTK GPS. And this is what we're looking at specifically, sedimentation in these areas, and this is what it looks like. Sometimes we'll get, clays and silts being deposited, but often it's these sands that the Rio Grande is famous for moving really efficiently. And the first place we're going to go is to the Rio Grande Nature Center, really close to here. And at the Nature Center, there was a high flow channel that was constructed, and a series of embayments and things that were constructed along the high flow channel. But I'm specifically focused on this high flow channel. And what we've done is we have a series of cross sections that we've been collecting. This is one of the sites that we've been collecting these data for 6 or 7 years at this point. So what that looks like when we look at it in cross section view is like this. So the dashed line is what the feature looked like when it was first built. And the 2 cross sections I'm showing here are one that's near the upstream end, where the high flow channel starts and water can enter the channel. And this one's about halfway down the channel. And the difference that I really want to highlight is just these are the same scale on the y-axis, which is elevation. Oops, I'm going forward, wrong button. The y-axis here is elevation, the same scale, and we see almost double the amount of aggradation at that entrance, which is very similar, like Todd was saying just a couple talks ago. So that's predominantly the kind of the observation that we see in these high flow channels. So most of the sedimentation is happening at the kind of where the water enters the channel. And this is kind of what that looks like. So I'm looking through the vegetation here towards the Rio Grande, and you can see that this channel, it's pretty well channelized at this point, but the bank is basically reformed at that entrance. So that's kind of where these things are collecting the most sediment, where we're actually establishing quite a bit of vegetation, which is exactly what we want, but it's preventing it's preventing flow from getting into these high flow channels until we get really extreme discharges. The next one I'm going to talk about is the bank terracing. So again, we're back at the oxbow here. And for the next two case studies, we only have very limited data. So we've been collecting data since 2012 from only 3 of these restoration features. We made a big effort in 2019, both pre and post spring runoff, to try and collect data at all 21 of them. So this is an example from the oxbow. And what we found here the oxbow has many different features. It has high flow channels, it's back flow channels, but it also has terracing. What we find here is I've added the red dash line, which is not the as-built. It's a pre-construction 2010 LiDAR. So just to give you a sense of kind of what we've done at this location. And what we see in the river, I should say, Rio Grande, is over on the river right here. So what we see is less sedimentation and some interesting things happening perhaps. The blue here is pre-spring runoff, and the yellow here is post-spring runoff. So interesting developments happening kind of near the Rio Grande itself, perhaps a small levee or something forming right there, a natural levee forming here. But the main part of this features is largely, there's very little sedimentation happening in the main part of the feature. The final, there it goes. Let's go back. The final one I want to talk about are these swales. And like I mentioned, there are 2 different types of swales that we've have engineered within the site here, or excuse me, within our restoration features in the Albuquerque Reach. The one I'm going to show here is one that's disconnected from a high flow channel, physically disconnected from the Rio Grande. That means that basically they're exclusively groundwater fed. And one thing that I noticed walking around these sites is that they still basically look almost all like this. So the ones, especially the ones that are disconnected from the Rio Grande, there hasn't been much recruitment of vegetation. The willows that were planted in these features still mostly look like they've they haven't grown as quickly as in some other parts of some other types of features that we have. And this is what it looks like from a sediment perspective. So this is a cross section through one of those swales. So again, the red line here is a 2010 pre-construction LiDAR. The brown line here is kind of what the design swale would have looked like. And we can see that there's again, very little deposition of sediment in this area. So from a sediment perspective, the types of features that see the most geomorphic change are, well, the ones that we expect. There's high energy features that have a lot of water moving and a lot of potential for sediment being deposited from the Rio Grande, and less so from these features like the swales. I just want to conclude here just by kind of giving a perspective again. I think this conference has been really beneficial, at least for me, because I've kind of been able to step back from looking at things from a geomorphic perspective. I've been so focused when I've been looking at these features at what's happening kind of with the dirt and the sediment that's below my feet. I forget the reason. I think I've forgotten the reason why we constructed these things, and thinking about the actual species and the different what were the goals of these types of rehabilitation features. And so I was going to conclude my talk today and say that, oh, these terraced features are clearly the best example of a type of feature that we want to construct, because there's tons of vegetation. It's a pain to walk through them, and they don't really, they've held up really well when it comes from a sediment perspective. But I think it's based on things I've heard this week or the last 2 days, it's clear that the swales do play an important role, especially for that southwest willow flycatcher. So there's a lot of work to do. We want to kind of expand on the surveying that we've done and do some modeling of these of the features to look at them kind of in a more holistic perspective, and then tie that back into the work that Tetra Tech and others have been doing, looking at the endangered species and how they're behaving within the features. So thank you very much, and I'll be happy to take any questions.
Thank you for your presentation. Are you saying that these types of sites where we've had the neckline terracing might be the most successful and best bang for the buck in terms of not getting a lot of sediment deposition, but getting really good vegetation growth?
That is, I don't want to say that, because I think in particular to the terracing, each site is what we found by kind of looking at different terracing projects at different sites, is that these actually maybe are the most highly variable. It does, from just walking around and kind of looking at the vegetation, there certainly seems to be more kind of recruitment of good vegetation in these areas, but it's also really close to the river. So if from the perspective of trying to expand and try to get water and recruit vegetation kind of farther into the bosque, these are obviously not the best example, but they are really good at near the river and kind of having that really good connection with the river. So I don't want to say that, because they're very highly variable, but this is a good example of something that definitely has worked. Yeah.
Okay. I mean, that's been my observation too.
Yeah.
I just wondering. Thanks.